Hi, I'm Klaus Kleinfeld, Chairman and CEO of Alcoa. Welcome to our first virtual field trip here in the UK. You will see many amazing things. Things that we work on every day at our plant here at Alcoa Kidscreen. You will see huge machines. You will see how many different parts for airplanes are made. You will hear from our team members how passionate they feel about their work. Enjoy the tour, learn about manufacturing, get excited about a career in this field. And seriously, who doesn't get excited about planes and flying? I do so as much today than on my very first day. So thank you for joining us. Have some fun.
Hello and welcome to all of you joining us both in the UK and the US. Now, in preparation to celebrate National Apprenticeship Week, Alcoa is sharing the opportunity to see apprentices in action at a premier aluminium factory, Alcoa Kidscreen in Birmingham, UK. Now, before we start, a couple of notes about the virtual field trip today. We would obviously love to hear from you, so share any questions you have with us via Twitter using the hashtag AlcoaVFT, and we'd also love to see you enjoying the show. So if you have pictures, share them with us too. The whole tour will last around 45 minutes, but if you miss any of it, it'll be available on demand after the show ends. Now, I'm going to be joined for the whole thing by Jim Wallace. He is the plant manager for the factory here, Jim. Let's just start, because I don't think anyone can fail to notice us in our high-vis gear, our safety gear. It is important here, though, isn't it? You wouldn't let me on without it.
Absolutely, it's a fundamental to Alcoa. The equipment that you're wearing today, from your protective shoes, metatarsal shoes, your high-vis. This area has actually been deregulated right now, so you can come in here without some of the personal equipment that we need. You would normally have gloves on, a hard hat, hearing protection, and that's just for this area. If you were working in the foundry, you'd have different type of overalls on that allows you to work with molten metal. So. Okay,
I mean, has it always been this strict though?
No, we've developed over time. If you go back a number of years ago, you'd be walking around a facility similar to this 40, 50 years ago without any PPE on. In fact, we've got photographs here back in the 1960s of people wearing shirt and ties and casting and things like that within the facility. So as time's gone on, our focus to health and safety has become more stringent. We learn from accidents and injuries, not only in Alcoa, but in industry worldwide. And then we look to resolve or make sure we don't have those type of issues in our locations.
Have you seen an improvement then? Have there been accidents?
Significant. If I look at last year, we had no lost work days at all in this location, which is significant for us.
Wow, that is amazing. Well, today, as you heard Klaus say, you'll learn about some very important products made here at Alcoa Kidscreen, materials that keep us flying safely, Formula One cars racing, and our soldiers safe in military vehicles. You'll also get a chance to meet the team who are excited to share why they think advanced manufacturing is a fun and exciting industry to work in. Now, this is a big place with lots of different careers, some you may never have heard of or considered. Now, while there are many exciting careers in manufacturing, we'll only be able to feature a few today, and with National Apprenticeship Week coming up soon, you'll hear from apprentices who'll share their advice too. But Jim, I want to speak to you about this place because it's huge. There are so many people working here. Why is it such a special place to work?
We just have about 500, just under 500 people work here. So we treat it a bit like a family environment. The reason some of the people that you meet today have got relations working here. So we do treat it that way. It's very informal, but our approach to what we make, our safety focus is very stringent, very strict.
And just tell us what actually happens here. What's the start process?
Well, aluminium all starts with bauxite. So it's dug out in the ground as dirt, it gets refined, and it comes to us as an aluminium ingot. And that's where our process starts for us. The story starts with that ingot coming into this location. From there, it goes to the remelt. We process it into an ingot or a slab, depending on what terminology you want to use. And then from there, it would go to our hot mill, through the hot mill itself, down to downstream operations, solution treatment furnaces, PT furnaces, sawing, packing, and our test house. But you'll see more of this in the clips that are coming up.
Great. Well, now that Jim's shared a little bit about what happens here at Alcoa Kidscreen, let's head over to the foundry and meet Magdalena.
My name is Magdalena and I'm working as senior metallurgist at Kidscreen factory. I came from Poland, Krakow. This, what you see there, is an ingot produced at our factory. From the liquid metal, through the whole process, it becomes solidified by water. Water is very important in our factory. Just behind me, you could see a huge cooling plant which has been built recently at Keys Green location. We're using borehole water to be environmental friendly and use this water with a special treatment to cool down our slabs. The very important part of my job is to make sure that those ingots meet a specification from our customer, from the chemical point of view, as well as mechanical properties. So we need to be very, very sure that those ingots are not cracked, hasn't got any internal porosity, or they have got very tight specification. I'm not going to touch this ingot because I don't know whether it's hot or not. But what you just saw, it was the ingot ID, which we use to trace our chemical composition and process parameters. Also, just the structure, it's not bad. It's actually good structure of the ingot, which is creating during the boiling point of the water when it touches our ingot. It's very similar, boiling water in your kitchen. Just before the phase when it's boiling, you could see small bubbles on the bottom of the pan. And actually, this is what you can see there. They're making marks, and it's mean that the cooling start right there. Probably you wonder why those ingots not stuck to the surface of the mold. Well, actually, exactly like you're frying your chips, we're frying our ingots by using the lubrication, which is going from the top of the cooling mold and touches the ingot surface just when it's still liquid. Aluminium is really amazing. Why? Well, actually, over 100 years, we're still recycling 75% of the aluminium produced in past. Currently at Keys Green, we're trying to aim to use 90%. Is it not wonderful? So what is actually difference between beverage can and airplane? The difference is that right here we're adding in our big furnaces magnesium, zinc and copper to make our metal much more stronger and better with mechanical properties. So now you wonder what's happening with the water which is coming through the ingot to the casting pits. We not waste it, we just recirculate it back to our new cooling plant, which recently we invest millions of pounds. What's happening here? Just right there, you could see the water with oil. The oil is removed by the skimmers, and then through the newest technology called the walnut shell filters, it's filtered to make sure that back to the processed water, it's very, very clear and good. Additionally, we're making a treatments to make sure that the water chemistry meet the final process specification. But what is very important as well is the bacteria control, which we do right here. So we're adding a chlorine, exactly the same like in the swimming pool, to make sure that our water is safe. Now there's something really for you. Don't afraid to try be an engineer in industry. It's fantastic. Make sure that you are focused on your maths, physics and chemistry. Don't forget to be curious, it's very important. And then just apply for some apprenticeship role in the industry. When I was a child, I was flying, and then I started to wonder how this plane is working. How can I make this amazing piece of equipment? Right here, now, I am a part of this manufacture. So, what is inspiring you?
Now, Jim, we just saw there Magdalena. She was talking about physics being important, maths being important, so subjects which I guess a lot of people, you know, maybe do like, don't like, but these are subjects that are quite important to manufacturing, is that right?
Yeah, without a doubt, STEM is going to be really critical to us. The science, technology, engineering and maths is a foundation that we will work on to help people progress further. So that's the sort of standard that we're looking for when they first come to us as apprentices, and then we'll move them through apprenticeships qualifications, and then maybe on to engineering qualifications. So that's the foundation that we're looking for.
And also there she mentioned about recycling. You guys don't waste an awful lot here. You try to reuse it over and over again, is that right?
Absolutely. I mean, aluminium is the most recyclable material that there is on the planet. It can be used over and over again. We have a position here where, well, energy. If we just look at energy alone, 5% recycling aluminium. If you take it out of the ground and have to refine it, you're using a lot more energy, so we can keep recycling it. Magdalena also mentioned about the water that we have. We have two opportunities with water. Last year we had a capital investment program that we built some new water towers, and we have a borehole on site so we can take groundwater, borehole water, and use that for our processes. Before that we were using town water. So town water is what you get from your tap when you switch it on. So clearly from an environmental point of view, it's better, and certainly from a cost of running the business, it's better for us as well.
Well, it certainly seems that Alcoa does their bit for the environment. I guess commitment to the environment, again, looks like it's quite embedded in what you guys do here.
Yeah, and another capital investment project that we're working on, which will come online at Q3 this year. So later on in this year is the fume abatement project. That's an 18 million investment that's part of the European legislation changes which are due to come into effect in 2018. So Alcoa are driving that project 2 years before it's actually required. So we get the benefits of that, but also Alcoa always tries to be further advanced than what legislation requires anyway.
Looks like they're doing their part. We've had a question come in. This is from Mrs. Green's class in North London. They're asking what courses should they take, I guess, for a career in manufacturing.
Yeah, we're back to STEM again straight away, without a doubt. It's the foundation. Now there's be children out there, young adults out there who will be sitting and maybe are more practical than academic. We have opportunities for those as well, but certainly for mechanical, electrical maintenance, for engineering, it is STEM.
Okay, well, there you go. Next up, you're getting an inside look at the plate mill where the ingots Magdalena showed us get closer to becoming the product that will leave the factory as part of an airplane or Formula One car.
Hi, I'm Danny Stokes. I'm the maintenance engineer here at Alcoa Kits Green, and this is the main 45-ton ball gear that goes into our bigger mill that's at the back here. There's a big gearbox that sits at the back which actually drives this mill. The mill roughly squashes metal into plates, which goes into all kinds of things: tanks, aeroplanes, Formula One cars, you name it, it goes into it. I started here 17 years ago as an apprentice, and I'm now the maintenance manager for the site. What's the difference between an apprenticeship and an internship? Well, an apprenticeship, generally, you earn and learn at the same time. So I felt the apprenticeship route was good for me. As a young boy, it was really exciting to get to come and work at a place like this. When you go to college, you get to come back the next day and straight away put that application to a practical use. Hi, John. How you doing?
I'm fine, thank you.
This is John. John, just tell us, the guys, a little bit what you do.
Well, basically, we will roll the cast slabs down to a certain required gauge. Slabs vary from 525 millimetres to 325 millimetres, and we roll right down to 6 millimetres. So that's part of the process we do with this machine centre.
And how hot are the slabs, John, when you put them on the line?
The slabs are roughly around about 450 degrees, up to near enough 500 degrees when we put them on the line.
I mean, just for you guys at home, we're taking slabs that are sort of this thick and we're squashing them down to kind of this thick, like foil that you get in packets at home. So there's a lot of pressure and a lot of force that goes on in the mill. I mean, John, how long has it taken you to learn how to do all this?
From start to finish, it can take anywhere about 12 months to learn.
It's a bit like flying a plane, really, with all the buttons and the joysticks around you.
It is, yeah. It can be quite confusing at times.
Well, John, I mean, these guys, they never get to see anything like this. I mean, this is a bit specialised and a bit sort of kind of secret, if you like. So do you mind showing us how you do it and we'll watch you roll a slab?
OK, that's no problem at all. So what we do now, once we've dropped this ingot into the tilt pot, we'll bring it up the hot mill line and we'll bring it up to what's known as the temp probe. This will take the temperature of the slab, and then we'll then generate what we call a hot mill rolling schedule. As you can see on this screen down here, this is telling you the temperature of the slab. Let's now put it up onto the hot mill screen, 406 degrees, and that's generated at what we call a hot mill rolling schedule. The slab dimensions at the moment are what we call a 924mm wide by 325mm thick. We're going to do a process which is called cross rolling, and we do this process to get the required width that the customer needs. So we're going to go from 925mm up to 1480mm on the cross rolling, and then I'll bring the slab back, spin it, and then carry on doing a process that's called straight rolling, which will give us the required length then. Another part of the process we do now is called edge rolling, and that will then smooth off the edge of the slab as it goes through. I'll now be sent up to the next process, which is hot shearing. That will be cut to the exact required length.
You guys just came from the operator's pulpit, where you see the operator reducing the metal down from 1/2 metre thick down to 6mm. This hot rolling mill can reduce up to 4,000 tonnes of pressure to reduce the aluminium to a thickness where it can be used on an airplane. I absolutely love what I do here at Kids Green. My job is to ensure that the material coming off the hot rolling mill is good enough to be put on an aeroplane. If you want to be involved in metallurgy or engineering, I encourage you to study really hard at school, especially in your science and maths, and always keep a curiosity for all things.
Now, Jim, we just saw there John saying it can take up to a year to learn how to run the hot mill. I mean, I'm guessing you then can't employ someone who's already come in with those skills.
No, the skills aren't out there to actually bring people in. We have to train that within the business itself. If you can imagine, the hot mill is 60 years old when that was actually fitted into the location, installed into the location and commissioned. So over the years, as technology's changed, we've added to the hot mill. We used to look at the mill itself as hammers and spanners back in those days. But obviously it's developed now. We're into more into technology, computers, models, PLC controls, ladder diagrams that are driving the actual mill itself. So the person in that seat driving the mill has to understand that and the interaction he has with the mill. And the product that he's putting through the mill is dynamic. Things can go wrong, things can change as he's actually rolling. He has to react to that within the heartbeat to make sure he doesn't do damage to the mill itself.
But like you said, it isn't the same technology that you had years ago, so I guess learning here is an ongoing process.
It is, yeah. For someone on the hot mill, 12 months worth of training would give him to a reasonable level, but further training would take him past that to what we consider to be competent. We train people here on a daily basis through Alcoa. I mean, from health and safety, which is a key fundamental to us, through to the Alcoa business system, driving initiatives of change. So manufacturing's changed from what it was 70, 80 years ago. We expect people then to come to work, do the jobs and go home. Now it's more fundamental than that. We want people to come to work, we want them to understand the business, we want them to help us drive it forward, to make sure we're still here in 100 years' time.
I was going to say, do you actively kind of encourage your employees to come up with innovations that could improve?
Absolutely, and we reward that. Okay. So we give people time to actually work on projects, and then we reward that as part of the instant recognition and reward systems that we have here to foster that culture of people understanding the importance of making the business successful, not only for today but for the future.
And what would you say there are any kind of innovations that have come up that you've seen yourself that people have kind of brought in and made the place better?
Yeah, some of the things that we were talking around in the test house itself, and some of the improvements that are made down there have been driven by people. You can see a lot of the activities that are taking place around us now. Again, over the years, people have had input at what they can affect within their area to make a change.
Amazing. Well, we've had another question come in. Students asking, what innovations does Kids Green have planned for the future?
Well, I guess the biggest one right now is that capital investment program that I referred to a few seconds ago. $18 million worth of investment. Now, that's a significant investment for any location to have, but it's to actually bring it in 2 years before it's actually required from a legislation point of view, shows the importance that Alcoa put across on environmental issues.
Yeah, amazing. Well, thank you. Now, we've heard from a couple of team members who mentioned they come up through the apprenticeship ranks, learning while earning, as Danny mentioned. Next, you'll meet a 17-year-old who's working here at Kids Green in the test house, learning about the mechanical property testing process to ensure product quality. Then you'll meet Danny and Tom and hear how their careers began as apprentices and how their careers have progressed since then.
This is a tensile testing machine where we break apart material for the customer's requirements. This is Slobber Dan. I've been working for him for about a year. Would you like to show him what the actual machine does?
Yeah, this is what we call number 8 test. Before we testing, we need to find what's the diameter of the test piece and enter in the computer. Then we set the machine in a starting position and open the door. And we have 2 grips that we use to hold the test piece in, put in the right position, close the door, and start the test. What we're looking at this point, it's graph, and it shows us how material reacts to the pulling out, and also give us how long it's before it breaks, and give us strength of the material.
I'm only 17 and I'm hoping my future carries on with Kits Green. I hope to see you soon.
Hi, my name's Danny. I've worked here for 10 years. I started out at 16 as an apprentice. I then went up to university, where I spent 4 years to work my way up to engineer, and that's what I currently do now. I'm currently a reliability engineer. And this is my friend Tom.
Hi, my name's Tom. I'm 22. I've just completed my 4-year apprenticeship in mechanical engineering, and I've just been promoted to craftsman.
What kind of things do you like working about here, Tom?
It's a very good environment. It's very friendly. Every day you walk past people, you always get a hello and a smile. I do love working in this environment, and people do think that it can be quite intimidating. What I would say to those people is it's not. And when you grow into the safety side of things, you start to grow into your own skin and become more confident in this kind of environment.
When I was younger, I didn't really know what I wanted to be. I kind of thought I wanted to be a pilot. And then just luck had it that I managed to get myself into a mechanical apprenticeship, and I found out that I really loved it. I then went on to college first and did some research into maths. I then went to university and then became a reliability engineer, which is really what I enjoy now. So some people have a misconception that engineering apprenticeship only has one end route, but we currently have 2 routes. So you can either take the craftsman route, like Tom is now, and then goes on to be a technician, or you can take my route, which I started out as a craftsman, but then I went the engineering route.
When I was younger, I did need that little bit of a push into this environment because it was all a bit alien to me, so I was thinking, what are the ifs and buts? But when I've done my research and looked into Alcoa and apprenticeships, I knew that that was the right job for me.
Now you guys saw Danny, Tom there. Jim, they're guys who come up through the apprenticeship ranks. I'm guessing people who are watching this, they're going to want to know, how do they even find out about these apprenticeship schemes?
We obviously advertise the apprenticeship schemes in the local area anyway, and we're trying to get local people, young adults, to come into the apprenticeship scheme. Okay. So one of the things that we do to sort of help that is we go out into the schools. Now, around this area, we have schools, for instance, very close to here, that the school children in the class are probably 32, 33, one teacher. So we try and help with that. And we're talking about 8-year-olds, 7-year-olds, 8-year-olds. We're trying to get them up to help with reading to get them up to a good standard. And that particular school, by the way, have got 32 different languages in it. So you can see the task the teachers have. But in addition to that, we're also looking at getting the chain of people coming through the education system to be of a good standard when they get to the secondary school, so the secondary school can develop it with the STEM type projects that we spoke about earlier. We still need to encourage people to come into manufacturing. So we, in addition, send people out who will go and work with the schools on what they call a "What's My Line." So they'll turn up. Sometimes they'll turn up wearing ordinary clothes, and the students have to guess what their task might be. Okay. Or they'll turn up with the uniform on or the PPE that they wear for certain parts of the tasks that we do within the facility. And again, the students have to guess what their roles would be within the organisation. And then that opens dialogue to talk about the sort of roles that we have and the advantages of coming into manufacturing as a career. I'm guessing that's the way in which you kind of encourage them to want to come and work at Alcoa more so than any other places. I mean, our reputation in the community is really important to us, and again, that drives people wanting to come and work here. So we can encourage people to through the education route to move into the STEM type activities for the more academic people who've got practical skills as well. But there's also opportunities there through our intern program for people who might be more practical than academically driven. Amazing.
Amazing. Well, how many apprentices do you roughly think that you take on each year?
Normally it'd be about 4 or 5 apprentices from a mechanical or electrical point of view. We also take on engineers, engineering graduate type roles. And one that we've taken on in the last year and a half or so is the test house. And someone is focused in the test house around the CNC machines to help move that forward, drive it forward. It's a critical role to the business.
Well, we're going to speak to one of those apprentices now. We've got Ava who's joining us. Hi Ava, nice to see you. So you are coming to work here, but I know there's a story behind how you got here. So just tell us, how do you even end up in a place like this?
Found out about Alcoa from my dad, who's been working here 30 years.
Oh wow.
He works over in the hot mill.
Okay.
And I did my work experience here through that. And then HR pointed me in the direction of an apprenticeship.
Right.
So it kind of just progressed throughout knowing my dad to here.
And just tell us, what's a typical day in the life of an apprentice at Alcoa?
Well, depending on what apprenticeship you've taken, you can be like mechanical, electrical, where you go to breakdowns around the site and you go to different areas. Whereas in my apprenticeship, you work on the machinery, you're cutting out the blocks to put on test pieces, to put on the testing machines, to break them, to see if they fit the specific requirements for the customer to have, if they fail or pass.
And you enjoy it, right?
Yeah.
You do, good. We've had another question come in here. They're asking for the best advice for students who'd like to pursue an apprenticeship. What should they study in school? I know what you're going to say.
Without a doubt, STEM. It's the basis that we want from people when they're coming through to our. They have to have some practical knowledge and practical experience, and I encourage people when they're going through the sort of the education process, STEM, to actually be inquisitive, think about things. I know the Discovery Channel do programs that show how things work. Think about the things that you come in contact with every day and how they sort of are made and the infrastructure that goes into making it. But we do need STEM. That's the key driver, because our intention is that we will build on that. And some of the people that you're talking to today have built careers here as apprentices, then moved on to engineers, for instance, and they move on to higher sort of qualifications.
You can vouch for that, right, Ava? Absolutely. Well, let's move. Testing is not something most people like, but here at Kits Green, there are teams dedicated to testing at various points in the process. Let's take a look at an important test to ensure all the materials leaving Kits Green are free from any defects.
Welcome to our ultrasonic non-destructive testing area. This is one of the inspection techniques that we use to assess the internal integrity of the product and to make sure that all the upstream operations have worked successfully and we get the product that's required by the customer. My name is Peter Glover, I'm the technical manager, so let's take you into an area that very few people see to see how this operation works. Let me show you something. A 2mm defect is about the size of this coin. So in a 3-ton plate, we're looking for a defect that is about that size. This is Dave Grant. Dave is a trained NDT operator. He's basically scanning a 4-ton plate and looking for indications that are 2mm or greater in size. So what Dave is looking at here is the A scan. This shows the front face of the plate, and this shows the back face. And this is the thickness of the plate, so we're looking for any indication that occurs through the thickness of the plate. If one of these indications breaks the defect gauge here, it shows up on the C-scan. And you can see that we have a number of indications that are showing up. So Dave is now going to each of those indications to evaluate the actual size. The evaluations we've done so far show that none of those indications are greater than 2mm. The maximum size is about 1mm, and that's acceptable according to the customer specification. So I took the opportunity to learn metallurgy, and it was something that I've never looked back on. I've really loved it, really enjoyed it. And I've worked my way up through the ranks from being a metallurgist, being a quality supervisor, quality manager, and finally a technical manager. And one thing I've learned in life is that you're never not good enough to do something. So if you believe in it, if you want to do it, keep on and you will succeed.
Now we just had a look at testing. Jim, they're mentioning they're testing for like 2mm defects. Now to any ordinary person, me especially, that doesn't seem like a lot. But obviously it must be an important thing if you guys are looking for something that small.
Yeah, it's significant. If you think about our process and what we actually manufacture here, we're manufacturing sort of multiple products. Defence material is some of the alloys that we use. When this is aluminium, this is what we put in there to change the chemical composition of the material for whatever we're making. So a defence product would be different than an aircraft product, for instance. Now, if you can imagine what we make from an aircraft point of view, we do the skeletal part of the aircraft. So if you just look at the wing for a second, if you can imagine the internal parts of the wings and the structures behind what you would normally see on an aircraft, spars they're actually called. So in flight, if you can imagine an aircraft wing and the movement that it takes, so it's on the ground, it goes up to 38,000 feet, it goes through a massive temperature change, then it comes back down again. But that wing flexes. If you're on an aircraft, you've probably seen it. Yes. So the wing is constantly moving. So if we have something, a defect within that material, then we can have a catastrophic failure. A crack could propagate from the actual defect, and that could cause a significant problem.
One of the students is asking what happens when an item fails a test.
Right, if it fails a test in here, first of all, give you some reassurances that our tests are significant and no product leaves here with any defects in it. So, if it fails a test, there's two issues for me. First of all, we cast it in the foundry and we only do this testing, ultrasonic testing, right at the end of the process. Right. So that causes, from a business point of view, causes problems from a costing. The actual product itself, if it's found to have a defect on it, it's scrapped off. Is the short story for it. We actually take the material and we turn it back into aluminium. So it will go back into the foundry. It's identified as scrap. It's all traceable, the reasons why it's scrap. We try and investigate why, but it will go back to the foundry and we use it again. So we get remelted and we realloy it depending on what we want to use it for.
Recycling again, like you mentioned earlier.
Yeah, and it's 5% to recycle. Aluminium in this stage, or in this part of the process, is 5%, whereas if you're digging it out of the ground, it's a lot more.
Do defects come up often?
We have defects in the process. It's a manufacturing process. Things do go wrong. From an operator point of view, the person might do something wrong, he or she. But from an inclusion point of view, which is what we're talking about from the ultrasonics, it happens occasionally, yes.
Okay. And what kind of skills do people need if they want to work in testing? What's the key skills, do you think?
The ultrasonic testing, we have various levels of non-destructive testing in the UK, and they have to go through rigorous qualifications to do that, which is external from Alcoa. Right. So there's opportunity for people to go through that. We have to have a level 3 on site who calibrates and checks everything that we do anyway. So, and even going down to checking what the operator's doing on a regular basis to make sure that he's still working within the requirements of that task.
And whereabouts does this testing come into the whole process of what you guys do here? Is it one of the first things that you're doing, or is it
If it's the ultrasonic testing, it happens towards the sort of more than halfway through the process, towards the back end of it. Okay. As we move plate through the actual facility, Ava spoke about the testing that she does in the test house. Yeah. Again, that's a critical part of the testing for us. We actually take parts of the plate and send it to the test house in parallel to the plates going through. So again, it's at the back end of the process, and the plates will be tested in the test house. And they could be there for 30 days, 40 days of testing. And
do you, when apprentices come in, do you let them have a chance at doing this, like from the offset?
It depends on what the apprenticeship role is. If it's a mechanical or electrical apprentice coming on site, we give them an appreciation of what happens on the site. Okay. They wouldn't specialise in the sort of test house area, but they'd certainly be aware of what we do down there.
Okay, amazing. Well, thank you very much. Now, today we've been lucky to be able to open the doors and give you an exclusive look at some pretty cool stuff at Kits Green. Working hard inside the plant is important, but working and giving back to the community is of great importance here as well. We were able to join the Kits Green team as they pitched in to work on the Meriden Adventure Playground, an absolutely incredible place. I'll let you see for yourself.
We are in Meriden Adventure Playground. My name is Ella. I'm a development metallurgist. Kits Green is a wonderful place to work because we are like a family, not just within the factory itself, but within the community, and not only donating money, but also being involved ourselves. It's a very satisfying thing to do because we're working with young children, young adults who are our future.
and they're going to come back and work with us. It's great for them to give them a sense of community, teamwork, a safe environment, fun environment that they can practice those creative skills by building things, and so both engineering and creativity coming together. So when I was in school, I knew I was interested in maths and physics. I went to university to do engineering. Then I did a one-year internship at Kids Green. And it was then that I absolutely fell in love with manufacturing.
It's what we took us weeks and weeks and weeks and months to do. They've done in the morning, it's amazing, and it's done, and it's like, wow, and I know that the kids will come back tomorrow and go, wow, where's this come? And they'll go, who's done this? And we'll go, Alcoa's done it for us. So it's amazing, and we can't say thank you enough. It's just fantastic.
If you're a girl and you have any interest in engineering or building your future, then definitely try manufacturing. It's a very exciting field, and there's so much us girls can do to make it even better than it is now. And I hope to see you all at Kids Green one day.
That adventure playground looked amazing. You guys obviously love contributing, I guess, to the community, to the environment, and we will touch on that again, but I just want to go over what we've already spoken about, because STEM seems to be the thing that comes up.
Absolutely.
And being important in an apprenticeship. So let's just go over what the importance is of that, of being practical as well.
Okay, from a STEM point of view, it's a starting point. When you leave school, the education program, you come into our industry, that's a starting point. We want to build on that. We want people to be the best that they can be, contribute to the business, and actually give people a very good career in manufacturing. That's what today is all about, making sure that people understand, students understand the opportunities that are within manufacturing and the opportunities that we can give them. So STEM's a starting point for us for secondary education. And here we try to grow our own, if I can use that term. They come in, people will come in with STEM as a basis, a base to work on for us, and then we'll put them through further education, and they have degrees in engineering, for instance, and move through the ranks here.
So they've definitely got room to progress after they get here as well. They're definitely always learning. And you said about being practical as well. People don't need to be scared off as such by those, subjects, like people do get scared by maths and sciences a lot.
Absolutely, and there is alternative routes. I mean, we spoke about some of the operations that we have here. The John on the mill, for instance, driving the mill. John came in as an operator, and he's been trained up at that level. Right. There is opportunities through the intern program to bring people into the business who've got the practical skills, but maybe not so much on the academic side, but have the practical skills to drive the business forward.
And I guess we should just remind everyone, it's not the same industry that it was 60 years ago.
Absolutely not. 60, 70 years ago, people used to come to work, and they were expected to come to work and go home again after completing the task. It's a different world now. We want people to come to work, we want them to contribute to the success of the business. To do that, we have to do things differently. We have to give people information to make informed decisions, and we want people to have an opinion. We want our workforce to have an opinion, and we run this as a family to make sure that we have a good culture going forward, and our activities in the community sort of help drive that. You've heard Ava talk about a father working here, and we've got multiple examples of that.
Amazing. You've had some amazing insights for us today, Jim. Thank you so much. We've still got one more part to come, but before that, I'd like to thank you for joining us for this exclusive chance to see Alcoa's commitment to the environment, the community, and how it's opened its doors to encourage students to consider exciting careers. Also, a reminder to teachers, you can go to manufactureyourfuture.com/UK virtual field trip to find Carson companion activity, and the virtual field trip will be archived on the site for future viewing. Now, like I said, we have got one more exciting part, and Chloe and Liam are joining me now. So you guys had the chance to go to Parliament and meet the Minister for Skills, Nick Bowl. Chloe, tell me what that was like.
I think it was really interesting to indulge in some British culture. Like, we saw Big Ben, the Houses of Parliament, and obviously meeting Nick Bowles himself was a pleasure. It was really interesting.
Liam, what did you take away from the whole thing?
The importance of physics and maths, like how many doors it opens within the future of jobs.
Okay. It's, being here today kind of giving you a good insight into what goes on here as well, do you think?
Good eye-opener.
Amazing. Well, Well, let's have a look at your trip to London. Thank you so much for joining us today. Jim, thank you again.
Thank you.
Let's see what happened when these guys went to London.
I'm the Minister of Skills. So my main focus is people who are going to FE colleges, people who are doing apprenticeships, and people who are getting some kind of training or skills support in their adult life.
National Apprenticeship Week is taking place the week after next. Why is this week important?
We had over the last 5 years 2.2 million people do an apprenticeship, and we've got this target to have 3 million people do an apprenticeship by 2020. So there are all over the country in every week of the year people starting apprenticeships. But it's quite good to have 1 week when everybody who's involved in apprenticeships celebrates the achievements of the people who are doing them and communicates the opportunities of apprenticeships.
What is it that you find exciting about the manufacturing industry in the UK?
I've always had a real passion for manufacturing because sometimes in some businesses it's quite hard to see the results of what you do and why it's useful. And with a manufacturing business, whether it's making paintbrushes or jet aircraft, you can see what is the point of your job. And what we've seen in this country, amazingly, is that actually our manufacturing industries are having a big revival. So it's really important to tell people that manufacturing isn't about the past, it's about our future too.
As a student who is only a few years away from joining the workforce, what advice do you have for those of us who want to pursue high-tech manufacturing jobs?
So I think the most important thing is to choose the right subjects, and perhaps even more importantly, not to drop certain subjects. So there are lots of girls who could have really great careers in high-tech businesses who perhaps somehow feel that physics isn't for them, that it's somehow something that only boys do. And it's really, really important that we get the message out that actually physics is for everyone, that maths is for everyone, that increasingly all of the interesting jobs will involve some level of mathematical understanding and of grasp of scientific principles.
With all the innovations around computers and technology, will humans become obsolete in the process?
Never. And indeed, actually, I know many people worry about the rise of the robot and that somehow robots are going to take all of the good jobs away and we're all going to end up working for the robots. Of course, that's not true, because the one thing that robots will never really be able to do is to be creative. I think for the next century or two, humans will always be running the show.
Thank you for giving us the time to talk to you.
It's been very interesting.